everybody. What I want to do this morning here is go over electrical charge and current. I haven't graded all the worksheets, but the ones I've graded so far I've had to make, in essence, the same comments and feedback over and over again. I don't know if you watched the video before you did the worksheet. I did post an announcement about that in Classroom. But when we're talking about electrical charge and current, you got this formula here, I equals Q divided by T, where I indicates current, and it's measured in units called amperes, or amps for short. Q is electrical charge, and electrical charge is measured in units called coulombs. And then T, of course, stands for time. Now, at the beginning of the year we talked about, well, I don't know if we talked about it, but there are standard units of measurements in the metric system. For example, the standard unit of length in the metric system is meter. The standard unit of temperature, it's not Fahrenheit, it's not Celsius, it's actually called Kelvin, which we'll talk about next chapter. The standard unit of time is seconds. So, when we're talking about, what you have to think about here is you have electric current. You have this amount of electricity that's moving through a circuit with respect to time. Well, it really doesn't take that long for the electricity to move through that circuit. So we measure the time in seconds. So the bottom line is your time has to always be in seconds. Not minutes, not hours, seconds. If your provided time unit is not in seconds, then you have to convert the time units to seconds. For example, on the electrical charge and current worksheet, question number 2 talks about here we go. We've got 180 units of charge, 180 coulombs in other words, and we're talking about a CD player. CDs, you hopefully know what they are. If not, just ask me. Anyway, the time designated in number 2 is 2 hours. A lot of you divided 180 by 2 and said, I got 90. The answer is not 90 because the time was not converted to seconds. So to convert 2 hours to seconds, there's 60 seconds in a minute times 60 minutes in an hour times 2 hours. When you take 60 times 60 times 2, you get 7,200. All right, so that should be the units of time for number 2 are 7,200 seconds. Then apply the formula, the number of coulombs, or the units of electrical charge here, 180 divided by 7,200 gives you your answer of 0.025 amps. In number 3, a lot of you said 6 divided by 3 equals 2. Yeah, but again, it's not right because you didn't follow the directions. This idea that you have to have the time in seconds. So that's how I got 180. The number of seconds in 3 minutes, 60 times 3, 180. Then you go ahead and multiply these two numbers here. You can put this over 1 and you have yourself a proportion. All right, 1 times Q is Q. 180 times 6 is 1,080 coulombs, way over here. All right, 1,080 coulombs. That's how you handle number 3. In number 4, a lot of you multiplied 680 times 0.137. The only problem with that is, if you do that, you get, I forget, the answer is 93.16. So, you cannot tell me that 680, like if we're going to put 93.16 back into the formula here and see if we get 0.37. But it doesn't work that way. You cannot tell me that 680 divided by 93.16 is going to be a number that's less than 1. It doesn't work that way. So what you have to do here, I've got the problem set up where I know my current, 0.137. I know the number of coulombs. I'm trying to find time. The best thing to do here, perhaps for a lot of us, is to just set this up as a proportion, then we're going to cross multiply and divide. So 180 times, or 100, let me back up. 1 times 680 rather is 680. and then we have 0.137 times t. All right, just again doing the cross multiplying thing. Then I divide both sides by 0.137. And when I do, I get an answer of, I believe it's 4,963.5 seconds. That's how you handle this one. So the moral of the story here with this relatively short video is to make sure that when we're talking about electrical charge and current problems involving this formula here, I equals Q over T, make sure that your time is in seconds. It might be provided to you in seconds like it was for number 1, where you took 9,000 divided by 120. Or in the case of numbers 2 and 3, they weren't provided, the seconds were not provided, but you had to convert from basically hours in number 2 to seconds, or like I did here, 60 times 60 times 2, or in the case of number 3, 60 times 3, right, because we're talking about 3 minutes, so in 3 minutes there's 180 seconds. So always make sure that time is in seconds. As I go through the rest of the worksheets here, I'll put the comments on there. I need you to do your part and go back and read my comments and make sure you understand it. And if if there's a situation where you don't understand, my feedback or whatever, please reach out to me. I'll be more than happy to email you, or better yet, come and visit you in person. So remember, time is always in seconds. If you have any questions, let me know. Thank you.